Hi, sixth graders. I hope you guys are doing okay. Today I want you guys to go over this, and what we're going to be looking at is how to use tables to explore equivalent ratios. Now, yesterday we did ratios. I know we're having a hard time with it, but we came up with the idea that this ratio is the same as this ratio. Even though the numbers are different, the ratio between the top and the bottom is the same. Because you can get here by multiplying by 2, and you can get here by multiplying by 2 as well. Okay, 2/3 equals 4/6. So those are the same ratios. Fractions are ratios because they show just a part of a number. But we're going to be looking at this today. So our assessor question is, how can you use tables to find equivalent ratios? So we'll be looking at tables like this and then getting ratios from them. Okay, so our first problem is Andrea is making a fruit basket for a school fundraiser. The ratio of oranges to apples in each basket is 2/5. Name some other ratios that are equivalent to the ratio 2/5. Okay, now, in order to do that, what we want to do is look at the multiplication table below. Okay, here's our multiplication table, bam. If you don't have something like this, create one just to help you, especially if you struggle with multiplication. The rows showing the multiples of 2 and 5 are highlighted. Okay, so it's right here, boom, and right here, boom. Find the ratio 2/5 by looking at the values in the two highlighted rows. Okay, so we want to look at the values here, and we want to look at the values here. When we look at the values here, we see that the first number in each of these rows are 2 and 5. That's exactly the ratio that we have, 2/5. So, this is when we multiply the numbers by 1. When we multiply the numbers by 2, we get 4/10. And so another ratio that's equal to 2/5 equals 4/10. Both of these numbers times 2. Okay, you can do that for 3, for 4, for 5, for 6, for 7, for 8, for 9, for 10. We discussed yesterday an easy thing to do is to add a 0 at the end of that, multiply each of the numbers by 10, add a 0, same proportion. 20/50 is the same as 2/5. They're the same ratio, okay? But let's look at 9 just to mess things up a little bit. Okay, well, 9 times 2 is 18, and 5 times 9 is 45. So the ratio 18 to 45 is the same as the ratio 2/5. They are equivalent, okay? Okay, we're going to use the multiplication table to complete this chart of equivalent ratios. So I'm going to have this up right here. Okay, 2/5. Okay, these are oranges to apples here. We have blank 6 blank 10, 2 blank 6 blank 10, 5 10 blank 20 blank. Okay, so 2/5. Now to get 5 to 10, okay, it's in the 2 column here. So we need to look in the 2 column at our 2 value, 2, 2, and it's 4, so 4 is going to go right here. Okay, when 2 in the 2 column, we're going to look for 6, okay? 6, that's in the 3 column. So if we go down 3 to 5, we get 15. Okay, I'm going to do one more, and then I'm going to let you do the last one on your own. If you don't do the last one on your own, don't worry, I'll take off a couple points. All right, let's get to 20. So 5 to 20, that's in the 4 column, okay? When we go in the 4 column to 2, 4, 2, we get 8. Okay, and these are all equivalent ratios. 4/10 is the same as 2/5, 6/15 is the same as 2/5, 8/20 is the same as 2/5, and 10 blanks is the same as 2/5, whatever this number is. Hopefully by now you're understanding the pattern. For this one, we grow by 2 every time, 2, 4, 6, 8, 10. And on this one, we grow by 5 every time, 5, 10, 15, 20. Okay, so hopefully by now you know what that next number is. Okay. Use the multiplication table to write 3 equivalent ratios that are not in the table of equivalent ratios. So Everything from here left is not, you're not able to use that. But you can use any of the ones over here. So I'm gonna write 1 and then I'm gonna let you write down 2. Again, you don't have to do it, but I will be taking off points if you're not able to. So I'm just gonna go straight for the 6. 2 times 6 is 12. And 5 times 6 is 30. So 12/30 is one ratio that is not included in this chart, but is equivalent to 2/5. Okay? How does the multiplication table show that multiplication can be used to write equivalent ratios? Because we can use multiples. That was a word that Juliana brought up yesterday. Multiples, so we're looking at 2, okay? 2 times 2 is 4. 4 would be a multiple of 2, and 10 would be a multiple of 5. So we can use the multiples in the chart to find equivalent ratios. The multiplication chart, I'm just going to put MC there. The multiplication chart shows us the products of the ratio components when multiplied by the same number. Okay, so what I'm saying is that when we take this 2/5, we can look at the components individually. That's what I mean by the components, the ratio components, the numerator and the denominator, and we can multiply them by the same number. But that's just by looking in the column. Okay, so I could have written that too. We can look in the columns to see what the numerator and the denominators, what the products are at that point. Remember, products are when you multiply two numbers together, the product is the answer. Okay, so we're going to stop right there. I'm going to give you a chance to copy that. Okay, that's a copy. All right, so let's reflect really quickly, everybody. Can division be used to write equivalent ratios? Well, if multiplication can be used, can we use the opposite of multiplication to find equivalent ratios? Well, in case you're not sure, take the idea of 25 100ths. 25 100ths is a huge number, okay? I can divide both of those numbers by 5. I know 25 can be divided by 5. When I do that, okay, so I'm going to divide by 5 and by 5. When I do that, 25 divided by 5 is 5. 100 times, or divided by 5 is 20. Okay, is 5/20ths the same ratio as this one? Is it an equivalent ratio? Yeah. Okay, so yes, division is just reverse multiplication. It can be used to make larger numbers more manageable. So we can use division to make those big numbers smaller so that we can work with them a lot easier. Because working with 25 would be easier than working with 250, or working with 10 is going to be easier than working with 100. So my example that I'm going to use, because it says give an example, I'm going to put 250 over 1,000, okay, divide by 5, okay, and that's going to give us a 50 over 250. Oh, I'm sorry, not 250, 200. Okay, same ratio. So that's my example. Does the multiplication table given in 1 show all the ratios that are equivalent to 2/5? Explain. No, it does not. Okay, let's go to that multiplication chart really quick. It only goes up to 10. There is an infinite number. Infinite is just a fancy word that means you can't count how many there are because it goes on forever. No, it does not. The table only shows equivalent ratios for 2/5 when multiplied by numbers between 1 and 10. Okay, so that chart only shows us equivalent ratios for 2/5 of whole numbers that can be multiplied by 10. It doesn't show us 11, 12, 13, 20, half. It doesn't show us any of that. It only shows us 1 through 10. If you need more time to copy that down, please pause the video and do that. You might have to rewind at this point. Okay. Number 2, Alex is flying a single-engine plane across the country, okay? While in flight, he engages the autopilot. So he's flying in his little plane. Good job, Alex. Okay? He engages the autopilot and the plane maintains a constant speed. The table shows the distance that the plane travels with the autopilot engaged for various amounts of time. So, at distance of 280, he flies that for 2 hours. Okay? At 3 hours, we're not sure how much he flies. At 560 hours, we're not sure how many hours that's been. At 700, we're not sure how many hours that's been. And then up here, we're not sure how far he's gone in 6 hours. Now, I can fill out the easy part of this chart, which is to go 4, 5. I'm going to assume that those are 4 and 5 because I have 2, 3, 4, 5, and 6. I have 2 and 3 and 6, and there's 2 spots in the middle. I'm assuming it's 4 and 5. Those are my context clues. Now, what it says right here for A is use the numbers in the first column of the table. Okay, 280, 560, 700. To write the ratio of distance to time. So, 280 over 2. Distance to time. So for every 2 hours, you go 280 miles. So you can write that like this. 280 to 2. You can write this like this, 280 to 2. Or you can write this like this, 280 to 2. I'll let you decide which one you want to do. How far does the plane travel on autopilot in 1 hour? Well, now we need to find the unit rate of that. Remember, the unit rate is how much of something do we have for every 1 unit, okay? And in this case, we have 2 units, and this is how far we go in 2 units. So in order to find the unit rate, we need to, that's right, divide 280 by 2. That's going to give us 1. So dividing 280 by 2, again, I want you to practice this. 2 goes into 2 1 time. Draw the arrow if you need to. I don't draw arrows. I was never taught that. 2 goes into 8 4 times. 2 goes into 0, 0 times 140 miles in 1 hour. Use your answer to write the unit rate. The unit rate is going to be 140 over 1. How can you answer B to be used to find the distance that the plane travels for any given number of hours? Okay? How can you use the answer to B, that's this one right here, 140 over 1, to be used to find the distance the plane travels for any given number of hours? Okay, so the distance equals the number of hours times what? Well, that's where the unit rate comes in. If we know how many units you get, or how many, what the distance is for every 1 hour that you fly, well, if you multiply that distance by the number of hours, you're going to get the total distance. Okay, so D, distance, is going to equal hours times 140, because that's how far you're going to get in 1 hour. So for every hour you're in there, multiply it by 140, that will be your distance. All right, now I'm going to scroll up. I'm going to keep this right here. I know it's hard to see, but it says really quick. Complete the table. What are the equivalent ratios displayed in the table? All right, so let's go back up to the table. So we're going to add 280 is how far we travel in 2 hours. We're going to multiply 3, plug that right in, 3 times 140, and that's going to give us the distance right here. Okay, so 3 times 0 is 0. 3 times 4 is 12. 3 times 1 is 3, plus 1 is 420. Okay, so 420 will be how far we travel in 3 hours, 560 and 4, 705. And then we would do the same thing that we did for 3. We would multiply 6 times 140, and that's going to be 840. Okay? Now, what are the equivalent ratios displayed in the table? So 141, that's our unit rate, okay? But we have 280 over 2. We have 420 over 3. We have 560 over 4, good. 700 over 5, okay? And then over 6. Okay, pause if you need to. I'm going to scroll up. Okay, so what information, for number 2, let's reflect on this really quickly. What information given in the problem explains why all of the ratios are equivalent? So let's go back up to that problem really quickly. Alex is flying a single engine plane across the country. That doesn't really tell us why all the ratios are equivalent. While in flight, he engages the autopilot and the plane maintains a constant speed. The table shows the distance that the plane travels with the autopilot engaged for various amounts of time. Okay, so this means that the rate is constantly moving at the same speed. So as time goes on, we're going the same amount of distance every hour because it's constant. It'd be like if you were on the freeway traveling 80 miles an hour. Now, luckily in the air, you don't have to brake as much. So let's go back up to our question. Okay, what information given in the problem explains why all the ratios are equivalent? The autopilot maintains a constant speed. Now I'm going to put that in quotes because that's actually from the problem, okay? The autopilot maintains a constant speed. All right, I'm going to give you a chance to write that down. Pause it if you need it. I'm going to scroll up otherwise. Okay, and then just looking down at it, it looks like 3 is our last reflection, our last explore. And we're going to be comparing ratios here. Sorry, that's a little dark. Okay, it says Anne's recipe for lemonade, I hope you can read this well, calls for 2 cups of lemon juice, okay, 3 cups of water, and Bailey's recipe calls for 3 cups of lemon juice and 5 cups of water. Okay, In Anna's recipe, the ratio of lemon juice to water is, so 2 cups of lemon juice for 3 cups of water. 2 to 3. Complete the table with the equivalent ratios. Okay, so 2 here, 3 here. 2 times 2 is 4. 3 times 2 is 6, good. Okay, 2 times what is blank, and 3 times 3 is 9. Well, because we're going 2 and 2, we're going to go 3 and 3. Okay, 2 times 3 is 6, good job. And now we're going on one more. Our initial reaction is assume, oh, we're just going up by 1, but right here it says 3 times 5 is 15. So I'm assuming that we're multiplying by 5 right here, okay? Because we're trying to keep everything the same. We want this ratio to be the same as this ratio, the same as this ratio, and the same as this ratio. 2 times 5 is 10, good job. Okay, so these are our ratios for Anna's recipe. 2/3, 4/6, 6/9, 10/15. So if you needed to make like 3 batches of that lemonade, you would go, okay, well, I need 6 cups of lemon juice and 9 cups of water. All right, in Bailey's recipe, however, the ratio of lemon juice to water is 3 to 5. 3 cups for 5 cups. Okay, lemon juice is right here. 3 cups to 5 cups. Okay, 3 times 3 is 9. 5 times 3 is 15. Okay, notice that in the first chart we went up 2 in the first one, but in here we're going up to 3 already. Okay, 3 times 4 is 12. 5 times 4, we want to multiply it by the same number, is 20. Okay, and then over here we have 3 times blank is blank, and then 5 times blank is 25. So I'm going to go right here. I know 5 times 5 is 25. Okay, that means I'm going to multiply 3 because we want to keep our ratios similar. We're going to multiply 3 by 5. 3 times 5 is 15. So that's my new ratio for Bailey's lemonade, or lemon juice, whatever it is, lemonade. Okay, so you have for Anna's 2, 3, 4, 6, 6, 9, 10, 15. For Bailey's 3, 5, 9, 15, 12, 20, and then 15, 25. All right, it says in each table there's a column in which the amount of water is the same. Circle these columns in the table. Okay, so I think we're right here. Okay, there's a column, these are columns, in which the water is the same. Okay, so let's look here. Where do we have water that's the same? 5, 3, no, that doesn't work. 15, 6, that doesn't work. 20, 9, no. 25, 15, no. But I have a 15 here, and I have a 15 here. So, in Anna's, when we look at 15 cups of water, we're using 10 cups of lemon juice. In Bailey's, when we have 15 cups of water, we're using 9 cups of lemon juice. We're going to use that to answer D. Examine the 2 columns. Whose recipe makes stronger lemonade? Okay, now assume that the stronger lemonade is made with more lemon juice and less water. Well, since they have the same amount of water, we can't go by that. We have to look at the lemon juice. And it looks like Anna's is stronger. I'm going to keep scrolling until I get right here. Okay, so I'm going to put Anna's lemonade is stronger. How do you know? So think about your answer. Okay, because she uses more lemon juice, that means that her lemonade is going to be a little bit stronger. Okay. The ratio of lemon juice to water in the stronger recipe is 10 to 15. Oh, I'm sorry, and we're comparing it. Is blank, then the ratio of lemon juice to water in the other recipe is 1 cup larger than the ratio of lemon juice to water in the other recipe. Okay, so 10/15ths, 9/15ths. Write the inequalities symbols to compare the ratios. Remember, those are boom, boom, greater than, less than, equal to. Okay, so is 10/15ths greater than or less than 9/15ths? Greater than. Okay, now you can simplify those. 10/15ths becomes 2/3, 9/15ths become 3/5, and you're gonna put boom. Okay, 2/3 is greater than 3/5. These are the same ratios. Divide this one by 3 and divide this one by 5. Describe another way to determine which recipe makes stronger lemonade. So think about how you could determine another way to of finding out which lemonade was stronger. Write down your answer, and then we'll go here. Marisol said Bailey's lemonade is stronger because it has more lemon juice. Bailey's lemonade has 3 cups of lemon juice, and Anna's lemonade only has 2 cups of lemon juice. Explain why Marisol is incorrect. Marisol did not consider how much water was used. And that's basically it. Okay, good luck. Thank you for listening. Pause if you need to. Go back and take notes if you need to. Otherwise, it's time for you to start on practice. Good luck. Have a great time, 6th graders. Ow, I just punched my keys. Peace.